The triad of latent potential in the void explores the concept of emptiness as a space filled with latent potential, transforming our understanding of void into one of possibility and creation. This triad demonstrates the principle of correspondence, showing how the concept of latent potential within emptiness manifests across different scales and domains of reality. In theoretical physics, the Dirac Sea presents a vacuum as an infinite sea of negative energy particles, suggesting that emptiness is teeming with potential. Shannon's information theory reveals that noise, often perceived as devoid of information, actually holds the key to error correction and information recovery. Meanwhile, in ecology, empty niches within ecosystems are seen as potential spaces for species evolution and biodiversity. Together, these concepts illustrate how emptiness, far from being barren, is a source of latent potential and dynamic creation. In the realm of theoretical physics, the concept of the Dirac Sea challenges our perception of emptiness. The vacuum, traditionally seen as void, is reimagined as an infinite sea of negative energy particles. When these particles are nudged into positive energy states, they create vacancies perceived as positrons or antimatter. This fertile ground of emptiness, as posited by Paul Dirac, reveals a latent potential within the void, transforming it into a wellspring of energy and matter. Richard Feynman beautifully captures this when he states, "The positron is a hole in the sea of negative energy electrons." Shannon's information theory further enriches our understanding of emptiness. Noise, which appears devoid of information, paradoxically holds potential for error correction and information recovery. Shannon demonstrated that by introducing redundancy and controlled noise into communication systems, one can actually enhance the reliability of transmitted information. This counterintuitive insight underscores that emptiness, noise, contains latent information essential for robust communication. As Shannon eloquently puts it, information is the resolution of uncertainty. In ecology, the concept of empty niches similarly transforms our understanding of ecosystems. These unoccupied spaces hold the potential for species to evolve and occupy them, thereby fostering biodiversity. The ecological void is not a barren space but a canvas for evolutionary potential, driving the dynamic equilibrium of ecosystems. Darwin's theory of natural selection illustrates this beautifully. In the struggle for survival, the fittest win out at the expense of their rivals because they succeed in adapting themselves best to their environment. By examining the Dirac Sea, Shannon's information theory, and ecological niches, we understand that what appears to be empty often holds immense potential. We also observe a universal pattern where emptiness is a reservoir of latent potential across different realms. Theoretical physics shows that a vacuum can generate particles, information theory reveals hidden data within noise, and ecology highlights how unoccupied niches drive biodiversity. These insights collectively demonstrate that emptiness is a dynamic space of latent potential, capable of fostering creation and evolution across different domains.